This lesson will help you interpret an equation in y equals mx plus b. So if we take a look at this first example here in our notes, it says the amount y in dollars that you raised by selling X fundraiser tickets is represented by the equation y equals 2x. Part A says graph the equation. So our y-axis, it tells us, is the amount of money that we earned by the fundraiser tickets. So our y-axis is going to be the amount earned, and the x-axis is the tickets, the number of tickets sold, the number of tickets. So y equals 2x. In order to graph this, we know that our slope is 2, and it has no plus or minus a number here, so we know it's a 0. That means it's going to cross at the origin. And our slope is 2, so we're going to go up 2 and to the right 1. So up 2, right 1, up 2, right 1, and so on. And when we connect these points, since they have real life meaning here, we can't put an arrow going down because we can't go into the negative. We can't earn a negative amount. And an arrow going up would work because we can earn more and more money. So here I need to show that we're going up by ones. Now you don't have to label all of these, but 1, 2, 3, 4, 5, 6, 7, 8. So my graph goes up to 8. Now instead I could go up by 2s or up by 5s, and then I would show more than $8 if I wanted to. 1, 2, 3, 4, 5, 6, 7, and this shows up to 8 tickets. So if I go by a bigger increment, then it will show more on my graph. Then we're asked to explain the slope, interpret what the slope represents. So in an equation, we know that the slope is the number in front of x. We know it represents the rise over the run. That means the rate of change is the slope. So what's changing each time? So the rise represents the y values, and the run represents the change in the x. So if the slope is equal to 2, we know that we could divide always by 1. So if we look at our graph here, the y values is the amount earned, and the x value is the number of tickets. So to explain what the 2 represents in this equation, we would say the slope represents the cost, which is $2, per ticket. So that is a rate of change. In other words, every time a ticket is sold, the amount earned goes up by $2. So that's how the graph is changing. It's changing $2 every ticket that is sold. It's increasing. Okay, then we're asked to interpret the y-intercept. So the y-intercept is the point on the graph where it crosses the y-axis. So it crosses here at the origin at 0, 0. So I need to explain what this represents. So if we look here, it's when there are no tickets sold, the amount earned is 0. So I'm going to explain that. The y-intercept represents the amount earned initially, so that means at the start, is $0 because no tickets have been sold. Okay, then we're asked to find the amount of money if 4 tickets were sold. So there's a couple ways to do it. We could look at our graph and go over 4, 1, 2, 3, 4. And then if we go up, it intersects here at 4 and then 4, 8. So this shows that when 4 tickets are sold, $8 are earned. Now another way to do it is to use the equation. Find the amount of money if 4 tickets So the tickets represent the x. So I'm going to replace the x with 4. And 2 times 4 is 8. So that is another way to get 8. Okay, let's take a look at example 2 in our notes. It says a car is traveling at a speed of 45 miles per hour. Once the car starts to brake, its speed s is related to the number of seconds t it spends braking according to the formula shown below. So pretty much we have someone driving, they're going 45 miles per hour, and then they're going to stop, they're going to press on their brakes. And so we all know that when you brake your car, when you push the brakes on your car, it slows down. So this graph should be showing how the speed of the car is slowing and coming to a stop. So we're going to go to graph this. Notice it doesn't use y and x. If you want to change it to y and x, go for it. But I'm going to keep it as s. So if we look here, s represents the speed. So this is the speed. And speed is measured in miles per hour. And then the t is the second, so it's the time in seconds. And if we go to graph this, we have to start. It crosses the y at 45. But there's a problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It does not go up to 45. So instead, we need to go up by, we could go up by 10s, we could go up by, I'm going to go up by 5s. So 5, and I have to put a number here so I know that it's going from by 5s here. So 5, 10, 15, 20, 25. I'm not going to label all of them. 25, 30, 35, 40, 45, 50. So my graph is going to start right at 45. So we're going to start here, and our slope is to go down 1 and then a half, down 1 and a half over 1. Well, instead of doing that, I would prefer to take this and write negative 1.5 instead as a fraction, because I like graphing with the fraction version of slope. So negative 1n, this is in the tenths column, so we got to change it to 5 tenths, which is the same thing as negative 1 and a half, which as a mixed number, because we know we can't have, it's better to write slope as a improper fraction, we get negative 3 halves. So the number in the front of x, instead of putting negative 1.5, we could put negative 3 halves. So we're going to go down 3 and to the right 2. So from here, we're going to go down 3, right 2. Down 3, right 2. Down 3, right 2. And then we're going to connect our points. I'm not going to put an arrow going down because we can't have a negative speed. And in class, people were saying, yeah, you can if you reverse. But reversing does not make your speed negative. It just means you're going 45 miles per hour backwards instead of forward. And we're not going to put an arrow up because we can't go into the negative side over here on the negative time. You can't have negative time. So it asks to interpret the slope. So the slope is negative 1.5. So that's the y and that's the x. So the y, if we look over here, is the speed. So miles per hour. And the x is the time. And we could always put a 1 underneath. So the slope stands for, and it's negative, that means it's decreasing. So the speed, it says over here, the y goes first, so we say the slope represents the speed of the car is decreasing 1.5 miles per hour per second. So then I also should label this to show that it's going up by 5s. I always have both of these going by the same increment. And the reason for that is because if you're wondering, wait, Miss Mizuko, you went down 3, but really it's not down 3. Instead, it's going down 5, 10, 15, and then 5, 10. So even though we're going by 5s, going down 3 and over 2, it's going to still reduce. It's going to still simplify to negative 3 over 2. So it's okay that we're going down 15 and to the right 10 because it simplifies to our slope, which is negative 3 over 2. Okay, now if we wrote this down, this slope, if we kept the slope as a fraction, it's saying that the speed decreases negative 3 miles per hour every 2 seconds. So that's what this is saying. So if we use negative 3 halves when we're explaining our answer, negative 3 halves is saying the speed is reducing 3 miles per hour every 2 seconds. I wanted to explain how many miles per hour per 1 second. This is called a unit rate when you explain the slope per 1 second, or in this case, how much for 1 ticket. Okay, then we're asked to explain the y-intercept. So the y-intercept is right up here. It's where the graph crosses the y-axis, so it's 0, 45, and I need to explain what does that mean. So you know the first number is x and the second number is y. So if we look at our graph, the 0 for x represents the time. So this y-intercept is saying at the beginning of time, initially, the car is 45 miles per hour. So when you think about it, this is representing the starting speed of the car before the speed goes down because of the brakes. So the y-intercept represents the initial, so that means the start, the initial speed of the car before the brakes are applied. And let's put what it is 45 miles per hour. Okay, then our next problem says find the speed of the car after 5 seconds. So here's the equation. Whoops, this is not a y, we have an s here. So it says find the speed, which the speed of the car is the s variable, after 5 seconds, and the time is t. So we need to take this equation, and we want to know what is the s, what is the speed, if the time is 5 seconds. So we're going to do negative 1.5 times 5 is negative 7.5, and then plus 45 is negative 37.5. Oh, nope, positive, because 45 is bigger. And the reason why I caught my mistake there is you can't have a negative speed, so that's why I knew I did something wrong. So the speed of the car is 37.5 miles per hour after 5 seconds. So the person presses the brakes, and in 5 seconds, this is how slow the car is going. Okay, part E. Determine how many seconds it takes for the car to stop. So the speed of the car, I'm going to copy down the formula. It says how many seconds, and the seconds is the time, so t, for the car to stop. And when the car is stopping, the speed is 0. So I'm going to plug into my formula 0 for the speed. I want to know when it stopped. So we're going to solve this equation. So I'm going to subtract 45. And then divide by negative 1.5. And when we do negative divided by negative, it's a positive 30. So after 30 seconds, the car is stopped. Now if you look at the graph here, 5, 10, 15, 20, 25, 30. That's what this represents on the graph. At 30 seconds, the speed is over here at 0. This point right here is 30, 0. So after 30 seconds, the speed of the car is 0. It's stopped. Okay, so for this next one, I'm going to focus more on answering these questions right here. I'm going to save the graph for you to do on your own. So if we take a look at this example right here, it says interpret the slope. So the slope is 5/4. And this says the equation y equals 5/4 x plus 10 represents the cost in dollars of the family meal when the food costs $10 and x beverages are purchased. So if we label this, this is y, this is x. So if we look at the y is the amount of money. And the x is the number of beverages. So maybe they're buying some soda, maybe they got an appetizer and then they're buying some soda. So the slope is $5 for 4 beverages. But if I want to know how much for just one, I need to divide these. So when I divide these, in one of our past chapters, we talked about finding the unit rate. And to find the unit rate, it's how much for just one. So that's what this fraction bar means, divide. So when you divide a fraction, you write it as a decimal, and this is telling us how much. Another way to write 5/4 is 1.25. So if we look, it's 1.25, $1.25 per one drink, one beverage. So to explain the slope, we would say the slope represents the cost, $1.25, per beverage. Per beverage. Okay, then we're asked to explain what this represents, what the y-intercept represents. So the y-intercept, this is saying that the graph starts at 10. So initially, the food bill is $10 before the drinks have been added. So the 10, when you're graphing this, the 10 represents the y-intercept represents the initial cost before beverages are included in the bill. So that's what the point 0, 10 represents. So the 5/4 represents the cost for each drink, and the 10 represents how much the food costs, it says. Okay, then we're asked to find the total cost, and the cost is y, of 4 drinks, and the drinks are the x, the beverages. So we're going to take the equation y equals 5/4 x plus 10, and we're going to solve this when x is 4, because x represents the drinks. And when we solve this, and if you rather put the decimal here instead, and you don't like fractions as much, we can get rid of this and put 1.25 instead. So the 4's are going to cancel and simplify, so we're left with 5 plus 10, which is 15. So the total cost is going to be $15 for 4 drinks. So you're going to get some food for $10, and the rest of it is going to be drinks. So the drinks are going to add on $5. Okay, then the last question for this graph says, find the number of beverages purchased, so the beverages are x, so we have to find x, if the total cost, which is y is the cost, x is the beverages, cost and beverages. So we're going to take the equation, and it says if the cost was $50, how many beverages can we get? So we need to solve this equation. So we're going to subtract 10 and multiply by the reciprocal. When we do that, the 5 will go into the 40 8 times. 4 times 8 is 32. So If you spend $50, you can get 32 drinks.